Hey everybody, it's Mr. Carr again. Today we're going to be covering 9.2. We're going to be looking at what kind of angles we can form inside of a circle. Okay, and we're going to do them with a variety of different lines and line segments. So we got a few more vocab words. First one is a tangent. That is a line that intersects the circle in exactly one point, and that point is called the point of tangency. This is what that looks like. If I have a circle here, and I go right here, it crosses right there as my point of tangency. Okay. A chord is a segment whose endpoints are on the circle. So any time that I can put 2 points together like that, that's a chord. We've actually already done one of these. We just have a special name for it when it goes through the center. It's a diameter. Okay. So that's a little bit of a key thing there, not a key thing, but just something to be aware of, that my diameter is also a chord. So we might do certain relationships with chords and diameters that kind of match up. All right, the next one's called an inscribed angle. That is an angle whose vertex is on a circle and whose sides contain chords of the circle. Okay, so that might sound a little bit weird, but basically what we're going to do is we're going to connect two chords like this. Okay, so all three endpoints like that, the vertex and the two endpoints, are on the circle. This is an inscribed angle. Okay, the intercepted arc, that is the arc that lies in the interior of an inscribed angle and has endpoints on the angle. So this is my inscribed arc right there. Or sorry, my intercepted arc. Okay, so this is the inscribed angle. This is the intercepted arc. Okay, so the first relationship we're going to look at is the measure of an inscribed angle in polygons. Okay, the measure of an inscribed angle is 1/2 the measure of its intercepted arc. So when I look at this diagram, my arc is AB here. The angle, so the measure of angle ADB is equal to 1/2 the measure of arc AB. Okay, and that's our first relationship we're going to cover. I also like to highlight the fact that if I kind of look at this, the angle is half the arc, but then I can also say that the arc is 2 times the angle. It might be helpful based on what you're given and trying to figure out. So I could say this, that if I take 2 times the measure of angle ADB here, that's going to equal the measure of my arc. Okay, so that's just a different way of kind of manipulating the relationship, because that is going to help us here on this first example. First we want to find is what is the measure of angle S? So that's that right there. Well, S, that angle, is intercepting that arc of 60. So just like we said on the previous one, the measure of angle S is going to be 1/2 of 60. So the measure of angle S is going to be 30 degrees. If I want to find the arc, RQ, it's actually this arc right here. So there's technically a couple of ways to do it, but here's what I'm going to do. The first thing I'm going to do is I'm going to take 37 degrees. So that's my angle QRS. Going here, I'm going to double that. So I can get to arc QS right here. Okay, so if I double that, so 37 times 2 is going to give me 74. Well, here's the thing. You notice very purposely that chord RS is passing through the center. This is a diameter. Okay, if it was not a diameter, I would not put point P on there. Okay, you wouldn't even see that. It would just be a straight line that goes across. But because I put it on there, it's not an assumption. I'm telling you that this is a diameter. So here's what I know. I know that going from R to S, that's going to be 180 degrees. So if I just want to find RQ now, then that means I can find that by doing 180 minus 74. So the measure of arc, RQ, is 106 degrees. Okay, that's our inscribed angles. We can go 2 ways. We can get the arc and take 1/2 of it, or we get the angle and we double it to help us with that. Inscribed angles. If two inscribed angles of a circle intercept the same arc, then the angles are congruent. Okay, and that makes sense because if I look at this one right here, find the measure of HGJ and the measure of, yeah, I don't like that. That's weird. I think that's supposed to say measure of arc HJ. So ignore that little angle symbol. Okay, so the measure of arc HJ. What do you notice about those? So here's what I need to do. I'm going to take the 39 here, and that is inscribed to that. So arc HJ is going to be double that one. So the measure of arc HJ is 2 times 39, which is equal to 78 degrees. Now that I have 78 degrees here, I'm going to look at this angle HGJ. Well, that angle intercepts the same arc. So therefore, the measure of angle HGJ is 1/2 of 78. And this seems kind of goofy, but I'm just doing the same thing to get back to 39. So that's how we know. That's like kind of a mini proof that we know that if the angles intercept the same arc like that, so they both intercept the 78 degrees, they have to be the same congruent angle. Okay? All right. So next idea, intersection of a tangent and a chord. So in this diagram, we've got my tangent line is here, that's tangent. Different from our tangents that we did in the trigonometry, okay? And then this one here is my chord. If a tangent and chord intersect at a point on a circle, then the measure of each angle formed is 1/2 the measure of its intercepted arc. It sounds a little bit weird, but again, we look at this angle here is angle 1, we'll call it. Angle 1 is 1/2 the measure of arc, that's going to be AB. Angle 2, if I look at that one, is going to be this one right here. Well, angle 2 is intercepting this arc. Okay, so that means angle 2 is going to be 1/2 of arc ACB. That's what we're trying to say here. And just like previously with the inscribed, I could go double if I needed to, right? Angle 2 is half of the arc, but the arc is double the angle. So if I have the angle of like, well, I'll see that down here. Okay, so if I go down to example 3, line M is a tangent, find the indicated measure. Measure of angle 1 is that one right there. So the measure of angle 1 is 1/2 of the 132. So that is going to come out to 66 degrees. I'm going to just double check my mental math on that one. Maybe. Yep, 66. Okay. Find the measure of arc EFD. So arc EFD is this one. So based on what I'm seeing there, 110 is my angle. So if I go from angle to arc, I'm going to multiply that by 2. Oh, there's the end of office hours. So the measure of arc EFD is 2 times 110. So the measure of arc EFD ends up being 220 degrees. Okay. Intersection of a tangent and radius. So this is one of our, definitely a key point of a tangent line. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius or diameter of the circle at the end point of the circle. Okay, so here's my tangent point of tangency. If I draw a radius in, that's going to be perpendicular to my tangent line. So we're going to practice verifying that and finding the radius. So we are going to do this with Pythagorean theorem. I don't like this first diagram because I'm not 100% sure. I think the 26 is the whole thing. I wish it was a little bit more clear. I think it's the whole thing and not just the outside section. Okay, but let's pretend for a second it was that. Let's say, 26 was just that piece there. Here's one thing I can kind of point out. This would also be a 10 there because that's a radius to go to from R to that spot. So this is something I like to highlight, that sometimes you can see that as being kind of double. And you see that down here, those are both marked as the radius, okay? But I'm pretty sure in this one that the whole thing is supposed to be 26. So here's what we're gonna do. We're gonna test what we did in the last unit. The question is, if this is a tangent line, then that means this has to be perpendicular. If that's perpendicular, well then that has to be a right triangle. So if I have these three sides, I'm going to test that out. Is 10 squared plus 24 squared equal to 26 squared? This is what we did in last unit. We did our verifying what kind of triangle is. So if these come out as equal, it is a right triangle. If these don't come out as equal, it's not a right triangle, therefore it's not a tangent line. That's my full explanation there. So if I do 10 squared is 100, 24 squared is 576, and then 26 squared is 676. And I do indeed get 676 equal to 676. Therefore, yes, ST is tangent to circle R. Okay, and again, what I proved was that these three sides make a right triangle, therefore it's perpendicular, and therefore that's a tangent line. All right, find the radius of a circle. So in this scenario, I'm telling you B is a point of tangency. So we know that we have a right angle there. So I'm just going to set up Pythagorean theorem. You got to be careful. Here's one leg right here. That's going to be R squared plus 77 squared equals this whole length, which is going to be R plus 49 squared. I put that in parentheses on purpose because this is how I have to multiply this out. It needs to be multiplied out as two binomials. So I'm going to distribute R and 49 here. Okay, so I've got R times R is R squared. Then I've got R times 49. And then 49 times R. And then finishing off with 49 times 49. So 49 squared, that's going to be 2,401. Then I could put these together, and then I get 98R plus 2,401. Okay, so that's what I'm going to have over here. Oh, and I got to do 77 squared there. So R squared plus 5,929 is equal to R squared plus 98R plus 2,401. From there, I'm just going to solve it out with algebra. So I've got R squared and R squared. They're actually going to subtract out. So they're gone. The other thing I'm going to do is I'm going to subtract 2,401 from both sides there. So that's gone. And then I get 5929 minus 2401, and I get 3,528, and that's equal to 98R. And let's finish my algebra up with division. So I get 36 for my radius. Okay, so I don't have any units, so I'll just say 36 units. So my radius is equal to 36 units here. All right, that's my point of, or that's applying my definition of a tangent line to my Pythagorean theorem. All right, and this is the last concept of today. Angles inside the circle, we're going to look at when two chords intersect. If two chords intersect inside a circle, then the measure of each angle is, take a wild guess, 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. Whoa, this sounds complicated, okay? And I wish there's more space. I was going to make my own diagram here. But bottom line is, here's my two chords, right? Here's angle X. So angle X, I like to think of it, kind of put those together. Angle X is the average of those two. That's really what's happening here. Angle X is 1/2 the sum of 112 plus 140. And so that's the idea, that we can kind of almost draw a straight line. If I look at the arcs here and here, then I can draw a straight line that passes through angle X, okay? I can also do the same thing. It's not necessary here, but I could go this way as well, all right? So that means that if I was looking at this angle here or here, remember they're vertical angles, so they're the same. So it doesn't matter which one I look at. But those two angles there would be half of the sum of JH and FG. So it's just making it kind of like drawing a straight line there. So X is going to equal to 1/2 of, let's see here, that's 252. And that's going to be 126. So 126 degrees if I did my math correctly. Yep, I did. Yay. Okay. So that's what angle X is. It is in between 112 and 140. So it comes out to 126. All right. So we got some you try now problems here. Just to highlight number 4 real fast. I'm not going to do it, but let you try it on your own. But when you look at 52, 52 is referring to this spot right here. And I'm giving you X and then this one. So if you do the same thing that we just did, well, I would actually start this problem by doing supplementary angles there. Okay, this angle is 180 minus 52. I'm just going to do this problem because this one's a little bit tricky. So 180 minus 52. So let me write that somewhere else here, which is going to give me 160, or yeah, 160. Nope. What am I doing here? Okay. 128. It's been a long day.
Hey, you want to talk? Could you please call?
Don't think you need the announcement on the video. So, all right. 180 minus 52 is going to be 128 degrees, which is right here. Well, when I draw that straight line in, okay, I'm relating X and 144. So if I do what I did earlier, which is 1/2 of the angle, well, I'm going to take 1/2 of 128. And that is equal to the sum of X plus 144. So that's how I need to solve this one. It's a little bit different than the setup from before, which is finding the angle, okay, finding the angle down in the middle here based on the two arcs. Now I'm giving you the angle and one arc. So you have to find the other arc by doing this algebra. So I do 1/2 of 128 is going to give me 64. And that equals to X plus 144 there. And wait a minute. Oh, I'm sorry. Let me rephrase. Let me redo that part. I totally messed up my setup. 128 is equal to 1/2 of the sum of the other two. My bad. Okay. The angle is half of the two arcs added together. So I can do this with the 1/2 distributing it, but personally I like to just do this. I'm going to multiply both sides by 2/1. Okay, because that way this will cancel out and then I don't have to deal with fractions. So if I do that, that's 128 times 2 is going to give me 256. Right, let me just make sure. Yep, 256. And that equals to X plus 144. Now I can subtract 144 to both sides. So that I get 112 as my X. Okay, so that's 112 degrees there. All right, that's it for 9.2. I know there's a lot of things going on, and it's going to take just some practice, so seeing all the different diagrams and making sure you're clear on what you're working on with that one, okay? So make sure you're practicing these out. Don't forget, you do get to use these references on quizzes and tests. So have some stuff available for your own benefit for that. All right, that's it for today. Take care. I'll see you later.